Imagine discovering that everyone who reached the same level in a video game simply vanished. Nobody made it to the next stage. They all mysteriously disappeared. This seemingly simple analogy might explain why finding life beyond Earth could be the worst news humanity has ever received. Sounds completely counterintuitive, doesn't it? We grew up dreaming of first contact, imagining what it would be like to exchange knowledge with other civilizations, discover revolutionary technologies, maybe even learn if they developed an intergalactic version of Wi-Fi. Hollywood has been selling this fantasy for decades. But there's a real scientific possibility that transforms this discovery into something potentially catastrophic for our species. To grasp just how absurd this situation is, imagine a massive party. You arrive at an enormous hall, perfectly decorated, music at the ideal volume, abundant food, cold drinks, everything prepared for thousands of people. There's just one detail. You're completely alone. Strange and terrifying, right? Now replace that party with the entire universe. The cosmos contains 3 trillion observable galaxies, each with hundreds of billions of stars. An astronomical number of these stars have planets in habitable zones, with liquid water and ideal conditions for life. Mathematically, it should be teeming with civilizations everywhere. But what we find is an almost deathly silence. This mystery has a name: the Fermi paradox. In 1950, physicist Enrico Fermi asked a simple but devastating question. Where is everybody? If the universe is so old and vast, why have we never detected unambiguous signals from advanced civilizations? No radio transmissions, no artificial structures, not even a tiny intergalactic sign floating around Saturn. Our galaxy alone could contain over 400 billion planets. Even being extremely conservative and assuming only 1% have conditions for life, we'd still have billions of potentially habitable worlds. To put a billion in perspective, if you counted one by one, 24 hours a day, without stopping to eat or sleep, it would take you 32 years to get there. Now multiply that by several billion possibilities distributed across 13.8 billion years of cosmic history. Consider also that many of these stars are billions of years older than our Sun. Civilizations that began when our Earth was just a ball of molten rock should have had enough time to spread across entire galaxies, building structures the size of solar systems, creating signals detectable from light years away. We should literally be tripping over evidence of intelligent activity. Faced with this statistical vastness, our apparent cosmic loneliness suggests something is fundamentally wrong with this equation. Either we're extraordinarily special, or there's a hidden mechanism preventing civilizations from developing beyond a certain point. This is where one of modern science's most fascinating and terrifying hypotheses comes in: the Great Filter. Picture this as an impossible final boss in a video game, the one that 99.99% of players never manage to defeat. The terrifying difference is there's no second chance or cheat codes. You get one shot, and failure means complete extinction. The question that should keep us awake at night is, has our species already overcome this deadly obstacle? Or is it still waiting for us? The Great Filter, developed by philosopher Nick Bostrom, must meet 2 specific criteria that make it truly lethal. First, it must be statistically incredibly rare, happening only once during an entire civilization's evolution. It's not something you can try multiple times until you get it right. It's literally all or nothing. Second, even under absolutely ideal conditions, it consumes geologically enormous periods of time to manifest. We're talking about processes that take hundreds of millions or billions of years, making our entire history seem like the blink of an eye. A genuine Great Filter must be simultaneously so improbable and so time-consuming that its occurrence seems almost like a cosmic miracle. And that's exactly why we've started looking at our own evolution from a completely different perspective, like detectives searching for evidence that we've already faced and conquered this type of impossible challenge. Analyzing our own evolutionary trajectory, we find frighteningly plausible candidates. The initial emergence of life, abiogenesis, remains a unique and unrepeatable event that defies our understanding. Earth spent hundreds of millions of years with apparently ideal conditions. Liquid oceans, relatively stable atmosphere, all necessary. Chemical elements abundantly available, but nothing happened. It was like having all the ingredients of a complex recipe perfectly measured, but the mixture simply refused to work. Then, seemingly out of nowhere, boom, life emerged. But here's the truly disturbing detail. This extraordinary event never repeated itself, not once, anywhere on the planet during the last 4 billion years. Even with similar or even better conditions available multiple times throughout Earth's history, abiogenesis remains stubbornly unique. This should make us seriously question whether it wasn't something far more improbable than our scientific arrogance initially assumed. Another strong candidate is eukaryotic cells, the foundation of all complex life we know. This evolutionary innovation happened exactly once and took almost 2 billion years to materialize, even after simple cells were already thriving. For nearly half of terrestrial life's existence, evolution was stuck at this stage. It's as if the universe said, "Congratulations on getting out of the primordial mud, but now chill for about 2 billion years before inventing something sophisticated like a brain." The transition to multicellularity, sexual reproduction, consciousness, complex language. Each milestone might have been a cosmic roulette wheel that landed on the right number only here. When we try to replicate these processes in the laboratory, the results are consistently frustrating. We can't artificially recreate life's origin or produce eukaryotic cells from scratch. This places us before two mutually exclusive possibilities, both disturbing. The first, relatively hopeful. We've already overcome our great filter. We've conquered the most improbable obstacles of cosmic evolution, and we're at the starting line to conquer the universe. We'd be the first to reach this point. The second possibility represents the true existential nightmare that keeps scientists awake. The great filter is still waiting for us. This would imply that absolutely all preceding civilizations managed to get approximately where we are now. They developed technology, built complex societies, maybe even started exploring their solar systems, and then simply disappeared without leaving detectable traces. Perhaps they were eliminated by global nuclear wars that made their planets uninhabitable. Maybe by irreversible environmental collapses that destroyed the capacity to sustain complex life. Perhaps by artificial intelligences that completely escaped their creator's control and decided organic life was unnecessary. Maybe by genetically modified pandemics that spread faster than any containment measures. Or perhaps by some type of catastrophe our current imagination can't even conceive. Something so far from our experience that we don't even know we should be afraid of it. We'd be happily walking toward this deadly wall, posting on social media, discussing politics, completely oblivious to the cosmic countdown ticking toward our extinction. How do we determine which scenario represents our reality? Unfortunately, we can't simply call our galactic neighbors and ask about their experiences, mainly because they seem to have stopped answering the phone long ago. All we have are indirect clues and circumstantial evidence. Ironically, the answer might be much closer than distant stars, in the microorganisms that might exist on Mars, on Jupiter's icy moons like Europa, or in the underground oceans of Enceladus, Saturn's moon. It's almost ironic to think that a microscopic single-celled organism, invisible to the naked eye, could determine humanity's ultimate fate. But that's exactly the bizarre scientific reality we face. A microorganism could literally rewrite our understanding of our position in the universe and our chances of long-term survival. Discovering even microbial life beyond Earth would be one of the worst possible news for our species. Why does this apparently crazy statement make scientific sense? Because it would definitively prove that life's emergence isn't a statistically rare event as we suspected. It would demonstrate that life can sprout relatively easily whenever basic conditions exist, like liquid water, energy sources, and some simple organic compounds. In other words, it would completely eliminate abiogenesis as our successfully overcome great filter. If life's origin wasn't our main evolutionary obstacle, then the real filter, the one that systematically eliminates all civilizations, still awaits us somewhere in the dark future. Worse would be finding complex life, eukaryotic cells in Europa's oceans, or fossilized multicellular organisms on Mars. We'd know that multiple evolutionary filters aren't exclusive to Earth. The truly apocalyptic scenario would be discovering unambiguous traces of extinct civilizations scattered throughout our solar system or beyond. Imagine finding ruins of abandoned temples on Jupiter's icy moons, cities buried under Mars' red dunes, technological debris floating silently in asteroid belts, or any concrete evidence that someone reached approximately where we are today, and then simply vanished from existence. In that terrifying moment, we wouldn't be dealing with abstract scientific mysteries or interesting philosophical speculations anymore, but with a practically guaranteed cosmic death sentence. If other civilizations manage to develop advanced technology, build complex and sophisticated societies, maybe even start exploring and colonizing other worlds, yet still couldn't survive long-term, what exactly protects us from suffering the exact same fate? Why would we be different, special, or lucky enough to break a pattern that apparently eliminated every other attempt throughout cosmic history? Finding life would answer some fundamental questions, but raise others we might prefer never to consider. It's like discovering fresh footprints in a silent forest. Someone passed through recently, but where are they now? What forced them to abandon the place? The Great Filter works like a shadow that grows with our technological advancement. The more we progress, the more power we acquire to manipulate our environment, but also the closer we get to discovering or provoking our own final breaking point. If we're the first to get this far, the entire universe is waiting to see if we'll overcome the challenges that defeated all predecessors. If we're not the first, we're retracing the steps of countless civilizations that failed. Perhaps modern science's true mission isn't just finding life on other worlds, but understanding how to preserve the life we already have. This responsibility begins with seemingly small attitudes: critical thinking, valuing evidence-based knowledge, supporting scientific education, and appreciating consciousness's fragility in the universe. The question, "Are we alone?" might never receive a definitive answer, and maybe that's better. The beauty of scientific pursuit lies in uncertainty, in exploring the unknown, in the willingness to ask difficult questions, even without guarantee that we'll like the answers. It's this uncertainty that motivates scientists, explorers, and dreamers. It reminds us that we're simultaneously fragile and extraordinary. Next time you look at the night sky, remember, each point of light might represent a shining hope or a silent warning about destinies we're still trying to avoid, because knowledge is just the beginning.